So welcome to this segment as I try to guide you. So this is a 50/70 paper 2 questions that I'm looking at. So you need to understand if you're doing pure science, then well and good, this is a good question for you. It says sodium chloride solution was electrolyzed using the experiment arranged as shown. So this is the arrangement. You can see electrodes, and this is a dilute sodium chloride solution. It says write down the formula of all the ions present in sodium chloride solution. Because it is a solution, it simply means there will be sodium ion, there will also be chloride ion, there will also be hydrogen ion and hydroxide ion. So all these are the ions that are present because the sodium chloride is in solution form, meaning it contains more components of water. So remember, you have sodium chloride, which has actually been dissolved in water. So from the sodium chloride, you are getting sodium ion and chlorine ion. From the water, you are getting hydrogen and hydroxide ions. Then B says, what observation would be made at electrode Y? Remember, electrode Y is connected to the negative terminal of the battery. Therefore, this is what we call as being the cathode. So the cathode is negative, and electrode X, because it's connected to the negative terminal, this is what we call as being the anode. And you need to remember that the anode is positive. If you are struggling to remember that, I want you to remember the mnemonic, panic, do not panic. That indicates that positive is the anode, positive is anode, then negative is the cathode. So what happens is that because the cathode is negative, meaning that those that are positively charged will migrate. So you expect sodium ions and hydrogen ions to migrate to the cathode. Then because the anode is positive, it simply means that chlorine ions as well as hydroxide ions will migrate and go to the anode. Now the question B says, what observation would be made at electrode Y? So because electrode Y is negatively charged, what is going to happen is that hydrogen ions are preferentially discharged over the sodium ions. The reason is because this one, the sodium is actually more stable and hydrogen is lower in the electrochemical series. So hydrogen ions will be discharged. And when hydrogen ions are discharged at the electrode, they produce a gas we are calling as being hydrogen gas. So now the question says, what observation would be made? So I would actually say that, effervescence, or if you want, you can simply say, bubbling of a colorless, odorless. So we can simply talk about odorless gas, hydrogen. So that's what you're going to see. So there will be effervescence, or bubbling of a colorless, odorless gas, and that gas is simply hydrogen, which is going to be, discharged in that place. So remember, when hydrogen ions are actually discharged in that case, they produce what we are calling as being hydrogen gas. You can balance up the atoms by putting a 2. It simply means you can put up 2 electrons that will be gained in order to produce hydrogen gas. And it is this gas now that will be forming bubbles at the electrode Y, and that's what you would actually observe. Hopefully you got the sense of what I'm trying to explain there. Then C says, write an equation for the reaction that takes place at electrode X. So if you come to electrode X, you have got 2 ions that are going, that will migrate and go to the anode, chlorine ions and hydroxide ions. Now, because, like I said, the anode is positively charged, these guys will be attracted. But which one is going to be preferentially discharged? So hydroxide ions are going to be preferentially discharged as compared to chlorine, because these hydroxide ions are actually lower in the electrochemical series. So they wanted you to write the equation. So when hydrogen ions go, they produce two things. So one, they are going to produce H2O, and you are going to produce oxygen. So what you do, you first of all balance up the atoms. If you look at it, I can put up a 4 there, meaning there are 4 oxygen. It simply means I can put up a 2 there. There will be 2 oxygen plus 2. That simply gives me 4. There are 4 hydrogen, there are 4 hydrogen. Now we balance up the electron. The overall charge this side is -4. So you can put on this other side plus 4 electrons. So that is the equation that is taking place at the electrode. Then D there says that what difference would be in the experiment if concentrated sodium chloride was electrolyzed? So now what difference would be in the experiment? So now in the case of what you are going to see, so there will be a difference when you're using concentrated sodium chloride. So when they tell you concentrated, it simply means there's little water that is actually available. And if there's little water, you are going to find that in a concentrated solution, the higher concentration of chloride ions, causes them to be preferentially discharged at the electrode. So because the chloride ions will be in high concentration, these are preferentially going to be discharged at the electrode instead of the hydroxide ions. So that is what you need to remember. Now remember, the difference that you are going to see is that when chlorine has been discharged, you are going to see, in this case, a pale, green gas, which in this case is, chlorine. Yeah. With a pungent, we can say with a pungent, smell. Yeah, so that's what you are going to be observed. So a pale green, that's a chlorine gas with a pungent smell. That is what is actually going to be, be discharged. With a pungent smell, let me say smell would be produced. Let me say would be produced, instead of oxygen. So instead of oxygen, you are going to find that chlorine, because it is highly concentrated. So those are things that you basically need to look at. If you want to, there are some rules, for the preferential discharge at each of the electrodes. So you need to actually watch out for that and go through those rules. They are actually going to help you in this case. Right, let's move on to E there. If you look at the E part there, it says explain why solid sodium chloride cannot be electrolyzed. So the question is talking about why can't solids, sodium chloride be electrolyzed. So the reason is very simple, because solid sodium does not possess ions. Yeah, so we can simply say it does not possess free, or if you want you can say mobile electrons to conduct electricity. So because it does not possess free or mobile electron to conduct electricity, no wonder solid sodium chloride cannot be electrolyzed, because an electric current will not be able to flow in the solid sodium chloride. Thank you so much for watching. Hopefully you learned something, you got some idea. Go through your rules for preferential discharge at either the anode and the cathode. Very important to